Well, I started out this talk to learn more about conventional commits because we use them. I work at UCLA Library, and we've been using them for I don't know, a couple of years now, or maybe a year. A lot of our projects we converted over to using conventional commits, and it's been a total boon. I just have to check this because I told Lars my husband not to text unless it was an emergency. And he just said, turn off the phone. So anyways, I wrote this talk for my dad so he wouldn't be bored sitting here. And I thought, it's Sunday, no one's going to show up. But you're all here, and I'm going to take a picture of you so I can show my dad later. And so smile, please. Thank you. So bear with this talk a little bit because I started out, I changed the name of it to the lexical semantics of Git. So it's from Git add to conventional commits. And lexical semantics is the practice of deconstructing words. I have to look at this because this is basically my talk here. It's deconstructing words to understand the meaning of things in terms of context. So it's breaking down words into their core. So it's about Git concepts from the beginning. So I assume you all use Git, right? So this might be a Git talk for your children or your grandparent or your parents, or I think it's pretty anyways. It's the A to Z to Git, but not quite. It's the A to M of Git because we all know Git is incredibly complicated. And let's see, okay. So the vocabulary of Git, there's a lot of vocabulary in Git, right? When you're starting out, there's so much Git stuff that you have to learn that as a beginner, you can imagine it's overwhelming. So the first section, we're going to go from beginning to intermediate to advanced, but really just the concepts and lexical breakdown of Git's vocabulary. So the first three are Git, GitHub, and version control. Using Git and GitHub, you create your code on your computer using Git and GitHub for version control. So the first question is, what is Git? Git is, I didn't really know this, that it stood for Global Information Tracker until I looked this up. Git tracks information, and Git is version control. We all know that. We use it every day for version control. How would you explain version control? Well, break it down to its root at version, and a version is just something that's different from other things of the same form. Version control is a way to track your changes, and Git is just a version control tool to track your changes. Git is version control. There's your version 1, our cute little rubber ducky that we all talk to, and here's version 2, our green rubber ducky. There's version 3, you've added a little something extra to him, and version 250, we now have a peacock. And you can always go back to version 1. Well, not that anyone really goes back to version 1, but you could, theoretically. So Git is a tool to track changes locally on your computer. If your computer happens to set on fire, all your changes are gone forever. So that's why we use GitHub. And what is GitHub? Hub is the central part of a wheel from which the spokes radiate. I'm a bicyclist, so I chose this bicycle hub. So the hub is also the center of an activity, region, or network. So GitHub, aptly named, is a centralized place to track your changes. It's an online platform where developers can create, store, manage, and share their code. And it's in the cloud. So GitHub is version control, Peacock, from rubber ducky to peacock. It's a way to track your changes. It's a way to track your changes on the internet. So when your computer sets on fire, which sometimes it does, all your changes are saved forever. And as we know, some are saved to the Antarctic. Who has changes? Who has Git in the Antarctic? Yes, and probably in space now too. I heard they brought the microfiche to space, so it's pretty cool. It is pretty much forever. And this is the GitHub, what GitHub looks like. That's my GitHub page. And the benefits to using GitHub version control is creativity and experimentation. You can experiment with your duck as much as you want and go back. You can securely save your data in case your computer catches on fire. And you can collaborate with other people and share your ideas. You can collaborate on one-on-one to do a project. You can collaborate with a team of people, and you can collaborate with people around the world. GitHub basically equals community. You can work together, share ideas, keep track of changes, and secure your data. So here's our vocabulary review. Now you can explain Git. Now you can explain GitHub. Now you can explain version control to your child and your parents and your partner and to anybody. Next up, new vocabulary. We're moving on to all the commit stuff, the Git workflow. So a branch is like a branch of a tree. That's where they got it from, I assume. And this is your main tree and branches, or it's not the best, but the roots of the tree is the main. And then when you make a branch, you get the exact same tree. Not really a branch, you get the exact same tree. So that's main, and then your branch looks identical. So you get the same rubber ducky. And from main, you do git checkout your branch name, and then you have a branch named update duck's color, whatever you want to name it. You make your changes to your branch. This is sort of where the branches look like on GitHub over there on the left. And the next concept is the repository. So the repository, the word just means a place, a room, or a container where something is stored or deposited, like a bank where your money goes, or that little box where all those kitties are stored, all the octocats are stored in the GitHub's box. Your code is stored in a repository. You have a local repository on your computer using Git. You have your remote repository online using GitHub. And as we mentioned, that your GitHub's in the cloud, so in case your computer sets on fire, it's safe. And all your repositories are in GitHub, and this is sort of what they look like there. So next concept is a commit. A Git commit, is to bind, that's just a commit. A commit is to bind or obligate by pledge or insurance. I commit myself to you to show up to this talk. That's why I'm here instead of at my father's bedside. So the latest changes that you're adding to your, so GitHub is the latest changes that you're adding to your repository, or I added the next slide. So we all know what a commit is. The commit is what you add to your repository, and you make your changes there. So your Git workflow is a series of activities that are necessary to complete a task. That's what a general workflow is just any kind of workflow you have, whether it's to clean your house or to rake your yard. You have a series of tasks. The Git workflow is, at its most basic, is you make a change to your code, you add your code, you commit your code with a message, and you push your code to GitHub. I suppose you don't have to do this last thing if you don't want to save it forever, but if you do, and you work on a team, it's your best bet. So back to step 3, and when you commit your code with a message, you use a commit message. So the commit message explains the changes that you made to your project. The commit tells the story of changes over time. The commit message should complete the sentence, when I add these changes, it will blibbity blab. It will, what have we done here? We have, Eric, what did we do? Right. So when I add these changes, it will change the color to the duck, or add a hat to the duck, add the sunglasses, add 2 wings to the duck. Generally, like, you add a verb and with the generalized thing of what you're doing, if you're just doing a very simple commit. So here we have change the color to the duck. So back to the Git workflow, you commit your code with a message, and you push your code to GitHub. So let's review. If you're not asleep yet, add commits with your commit message and push your changes from your local repository in Git to your remote repository on GitHub. 1, 2, 3, 4. So then you are sharing your thoughts and ideas with your team and the world. And our vocabulary review, now we know Git, GitHub, and version control. Repository, local remote, add, branch, commit message, Git workflow, and push. Did we cover push? Yes, we did. So that's quite a decent amount for a short time. New concept. So pull request. So a request is just asking for something to be done. I asked if I could speak here. They said, sure, Jen. So a pull request is a method of submitting contributions to a project. It's also a proposal to merge a set of changes from one branch into another branch. Usually you're merging into main. Usually, not necessarily, but it's usually the case. So you're asking the question, can I change the color of the duck, please? And you use a commit message to submit your pull request. And your commit message says, change the color of the duck. And this is within your Git workflow, is your pull request. And a pull request, is this actually a pull request? Yeah, this is a pull request. We have, in my team, we have and I'm very particular about our pull request. This is a very old pull request I did, where it's just super simple, but generally connected to ticket and what you did. It's nice. I really like to leave comments and messages in the commit message to be super clear, and you can use Markdown, which is, it's nice to be clear, so at least your future self will know what you did if no one else looks at it. Here's another pile of old pull requests from, 2013, and even more. Okay, so these are guides to write good pull requests. Oh, there are guides to write good pull requests, commit messages, and branch names. The main thing is to make them meaningful and agree on the format with your team. And it's definitely best to use the standards of the community, or people are going to mock you mercilessly, as we all know. So the new concept that's next is the merge. So merge is to combine a form or a single entity into a single entity, right? So 2 things become one. So our branch and from main and your branch change duck's color, turn into one branch that is just main. And there's your pink duck and your green duck, and you say your commit message, change the color of the duck, please. And yes, you can merge your code, and once it's merged, then we're all happy, and the changes are accepted, and the branches are merged, and you have your green duck is the main branch now. So the next concept is what we all hate, is the merge conflict, right? They can be very complicated, and sometimes it's better just to make a new branch. But at its most simple, and sometimes it's nice and easy. You just make your choices and decide which duck, which color you want to keep. This is a pretty nice, simple change. So both branches make changes to the same thing, and you have to decide which one you want to merge to main and keep in main. And we decided we're going to keep our duck green because happy St. Patrick's Day. Now we'll review the vocabulary, blah, 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 and pull request, merge, and merge conflict are our new ones. So now we're all the way up to intermediate. You still with me? Thank you. The semantic versioning. So who uses semantic versioning here? Pretty much everyone, right? Because it is a standard. So the semantic version, just semantics, is singular, but it looks plural, right? But it is the study of meaning in language. So commit messages tell a story. Semantic versioning tells a very specific story. The story helps you keep track of your changes. The story gives your team a standard to work with when you're doing your versions. Semantic versioning is the standard that the community uses all over the world, right? Since Semver, I don't know when was Semver invented or proposed, a long time ago. So semantic versioning is 3 sections: the major, the minor, and the patch. The major is incompatible changes, like when you say, oh, this is version 1, version 2. Minor is changes to functionality that are just features generally, and things that you can are compatible with your version. And a patch is basically bug fixes or chores or styles or performance fixes. There's our major, and is the patch. Oh yeah, look at me. Changes to functionality is that's a minor patch and a minor and a patch. And okay, this is more explanatory. Here's our patch. We've just changed the color of the duck. That's pretty minor. No one's gonna be sad. Let's see. This got a little garbled here, sorry. Okay, so that was the patch. This is the change to functionality, right? That's pretty different. This is not the same duck. This is a very different duck. His function has changed. He's now like doubly floating, and he has a hat, and so that would be a minor patch, and you would keep the patch version as well, because we haven't updated the major version yet. So this duck has changed so much, we really can't go back from the killer duck. So once you get to this point, you have to just change it to version 2. Everything resets, the minor patches and the minor and the patches reset, and you just start all over again. And you move on from there, because it's incompatible at this point. So that is our vocabulary, our new vocabulary, which is the semantic versioning, minor, major, and patches. Next, we have our changelog. Change just means to make something different. I changed my outfit only 2 times today. No, really, I didn't. And a log is an official record of events. So a changelog is just a log of notable changes made between each release or version of your project. I don't know if you use changelogs, but we use changelogs, and we use GitHub Actions to create our changelogs now. So we don't even have to write them, which is much nicer. But it's nice to have a record and a log of your changes over time. You can see there's our semantic versioning at the top, and the date that it changed, what changed within it on that date, and a message about it, and as well as the ticket number and the pull request number with links to them, so that you can always see what they're connected to if something breaks, which is really the only reason you need them. So these are the types of things that you might see in a changelog. All these different things, change the colors, that you added things, that you're delivering software, but face-to-face, I don't know what, oh, that's from an old slide. Sorry, I copied these from an old talk. So issues are the next topic. An issue is a topic to be thought about, right? Like if you have issues with your friends, and you have to talk it out. So you have to think about it and you have to talk it out. GitHub issues track tickets, ideas, feedback, tasks, or bugs. If you've worked in open source issues, people submit issues so that things can get done. People submit ideas, they submit feedback about things not working and bugs that they see. And when you work on a team, you can use the issues to track tickets. We've done that when we were creating components. You can either use a work tracking tool like Jira or whatever, or Pivotal Tracker, or whatever you want to use. But GitHub issues is a nice place to track your issues as well, or your tasks, because then you can link all your other GitHub PRs there very easily and close it automatically. Next is template. So a pattern used as a guide to make something. So like you have a template for a cookie, making a cookie. You have your cookie cutter. So we can make a whole bunch of cookies because we have a cookie cutter. So we use templates in GitHub to make all sorts of things. You can create a template that every time you create an issue, you can create the same template. So we use this to create issues to make components. So every time an issue is created, like create new issue, it comes up and you can fill in the blanks of all the info, like what are we calling this? Every single thing, anything you want the issue to say, you can make it say. You can have, what else can you do with issues? You can have help if you want, this is a really good one. You can have your pull requests have a template. So we also use that, so that it enforces people to write like that it's connected to a ticket, and how you have your PR that it's linked to, and everything's laid out so that people can fill in the blanks so that people don't get lazy about making their commit messages. Because we all know we get a little lazy when we're working fast. So our vocabulary has expanded into changelog issues and templates. Now we've reached advanced. This is like when you go to the ice cream store, and if you can eat all this ice cream in an hour, then you get a free ice cream. So you all get a free ice cream. Or maybe that was just Friday if you were here. So release. So release is to make something available to the public. And a GitHub release is a way of packaging and providing software to your users. So this is our release, and this is using our semantic versioning again, and as well as GitHub Actions and a plugin so our releases are written. We don't have to write them anymore. We used to painstakingly write them, and I set up a whole Confluence page of how I wanted them written because I would get very fussy about people writing it wrong. And now they're automatically written, even with the emojis, which is just makes it a little more fun to look at. All right. So the bug has the bug, the chores and the updates, and it shows the contributors. It shows what happens. And the cool thing about releases is that, and this has happened to us on many occasions, is that when you have a release and you push your release to production and something goes wrong, you can just go back to your old release and push that old release to production and figure out the bug, and your site's still working. And everyone's happy, at least for a little while. So conventional commits are, a convention in general is an agreed upon way of doing something, right? Like the convention hall. Oh, that's not a good one, is it? What's a convention? Someone. Driving on the right side of the road. Oh, driving on the right side of the road. I like that, yes. Okay, so conventional commits is a set of rules to follow to write your commit messages. So does anyone use conventional commits? I do. Yeah. We worked with a developer in Brazil for a little while, a young guy, he was like 20. He came onto our team and he started writing his pull requests, and I was like, that's not how we do it. We write it this way. And he was actually writing conventional commits, and we hadn't used it yet. And then our UX team had adopted conventional commits, and so it developed from there. And their commits were just so beautiful looking, and their pull requests and everything, we decided to adopt it for our projects. So conventional commits combine your commit message, your semantic versioning, and your pull requests. Instead of writing change the color of the duck, you would declare what type of change you're making. So the color, so there's a bunch of available types. There's feet, which is a new feature. You have to write, and I didn't put this slide, but you have to write the type, colon, and then your message after that. You can write in brackets before the colon some other more contextual words, but the basic structure is what you've done, what type of thing it is, and then your message, your general commit message, like change the color of the duck. The other available type is fix, which fixes a bug. Docs, documentation only. Style, changes that don't affect the meaning of the code, like our duck would be style. Styles, white spacing, formatting, missing semicolons, stuff like that. Refactor, a code change that neither fixes a bug or adds a feature. Perf, performance, which is a code change that improves the performance. Test, to add missing tests or correcting existing tests. And build, changes that affect the build system or external dependencies, like gulp, broccoli, npm. Those are obviously JavaScript things, but of your choosing. CI, continuous integration, changes to our continuous integration configuration files and scripts, like Travis, Circle, Browser Stacks, Sauce Labs. Chore, other changes that don't modify source or test files. You know what a chore is. It's a chore. That's why it's called something like that. Revert, something that returns to a previous commit you've done. And this is how our pull requests look now. So you can see it tells a story. Like we generally have been using mostly fixes, chores, feature, CI. Like you kind of get to see, oh, we're doing a lot of the same thing over time. And it makes it kind of easier to screen when you're looking at it as a whole. So actions, it's the process of doing something. GitHub actions allow you to automate your build, test, and deployment pipeline. Conventional commits with the GitHub actions, that's where the magic happens. That's like conventional commits on their own, they're pretty, but GitHub conventional commits with GitHub actions, it's very powerful. You can use the types from your semantic commits to create workflows to do things automatically. And automation is the key to developer happiness and DevOps happiness. Well, probably not, but DevOps happiness a little. You can create workflows that automatically test your code, that automatically release your code, and that build and deploy your code to whichever environment you want. And you can choose which of your semantic versioning triggers those cycles. So these are the ones that we're using here on the left, the actions we're using like to manually rebuild and deploy and to release. And what I've realized that automation is magic, but you can use it in multiple different ways. Like 3 of our different projects are using the semantic versioning with the semantic versioning with the GitHub Actions in completely different ways. Like you can even test your pull requests with the GitHub Actions. Like when we submit our pull request, you can set it to check that you've checked your title, that your title has a semantic version in it, that you have a label set, that you've done all your tests are passing. You can use it for deploy, like I said, and yeah, you can use it to automatically trigger pretty much anything that's within the the conventional commit workflow. You can set it up at your pleasure. So our vocabulary has really expanded. And I will say, as closing, that lexical semantics is the key to understanding the concepts of many things, including Git and GitHub, and why they exist. To share ideas, to work with other people, to work with a team, and to work within the community. Thank you. I don't know if I can answer any questions, but I could try. Yeah.
Well, just a comment. It was great. I had no idea Git stood for global.
Me either. Yay, you learned one new thing. Yay. Yes. Yeah. Yeah, it's been nice for our team. We've really enjoyed it. Yes, Ashok.
For the things that are marked, so I saw for features that you have like a ticket number associated with them.
Mm-hmm.
In your system, do you also mark things that are like chores or CI or any of those? Are they also created as tickets in the system for tracking, or you just
Yeah.
that as part of a thing that?
Yeah, that's part of the semantic, the conventional commit types is chore. Like I think what we have set up is like our build only, the release only gets made if things are automatically merged in one repository if it's accepted, if it's a feature, if I think just features, and then if it's labeled a bug fix or a chore, it doesn't automatically build the release. It waits, lets them build up, and then once there is a feature associated with that collection of commits, then it will automatically build a release. But it doesn't have to be like that. You can set it up in the Git workflow however you want. Yes. Conventional what? What I like to do is we use Jira for tracking. So I always put the ticket number and then underscore, and then the name of exactly what it says in the ticket, so that it's really easy to go back and find the ticket. So that's how I like it, because we push our tests to Percy that takes a snapshot, and so when we run the Percy commits, it has a list of the branches that have run tests. So you have to find the branch to press the button to run the test. And if you don't put the ticket number, it's super hard to it's just annoying to find the stupid branch name. So that's what I like to do. Or I guess if you don't have ticket numbers, you can always write I used to write my initials first, and then generally kind of exactly what you're doing, like add change the color of the duck. The same thing that my PR message would be. I would do that. That's, yeah. When I write the commit message, yeah, like for the PR, the commit message for the PR, yeah. Yes. We have a format that I set up. Yeah, it depends on the repository and what we're making. Like we have them set up differently for each repository and what we kind of are doing for there. So some of them is like, did you release it here and check it? Did you release it here and check it? Kind of a checklist so that we got this from Funkhouse. We worked with Funkhouse, and they work with outside vendors, so a lot with outside developers. So they had a really tight checklist of like, how long did this take you? Did it work here? Like, does it look like it's supposed to look like? Did all the tests pass? So there's those checks, and so we adopted some of those, and then we also always put a link to whatever ticket it came from so that you can find it later. And then I generally take a snapshot of it working and put the snapshot in there and kind of put any notes of if anything else needs to be done later or any other notes that could help future me or anyone who's reviewing the ticket that would help them merge it. So if you're like, okay, I added this code, but when I saved it, for some reason, all the text got rearranged, and so the pull request looks crazy, but I only made this change, and this change. So when you look at the file changes, you're going to see it says too big to look at. It's like, and it's not. I only did these three things. Look at this line, and this line. That's what I like to do.
All right, so you taught us what Git stood for. Thank you. Do we know what the little octopus guys are about?
It's the Octocat. I love the Octocat. I don't know. Well, I heard that the person who made the Octocat only got paid $200 for that logo, which, all right, it's the story of being an artist. But let me see, I'll go all the way back to the top. I made my own Octocat, so I think it has something to do with, yeah, there's a lot of slides. I think it has something to do with it has multiple tentacles, right? So it's kind of its own hub, right? That's what I think, it is a hub in itself, an octopus, right? That's the one I made for myself. And I think I made it in Illustrator, but I think there's a website you can make your own, because you saw all those awesome GitHub stickers. Oh, which I meant to bring, but I forgot. Yeah, any other questions? No matter how basic or advanced, I don't know. All right, well, thank you so much. Thank you. Yay.